切哦，音频我切一下。Hello Hello 啊，这个有你那个按一下它那个开机一下。啊，那个镜啊，连上了吗？啊，你开始吧。Hi everyone, welcome to our EasyEDA tutorial live stream. I'm super excited to have all you here today. So today we are going to design a keypad from scratch with EasyEDA. The keypad is shown in my hand, and my name is Mao Weiling, and you will be I will be honest to you for this section. Right here with me is Selena.
Hello everyone, welcome to EasyEDA's live stream. I'm Selena, a hardware engineer in EasyEDA. Today is my great honor to explore the Keypad project with all of us. We have prepared giveaways. Please get your EasyEDA customer codes ready.
Yes, so let's switch to our sorry, let's introduce our EasyEDA pad first. Well, this pad is accomplished with EasyEDA, and it is a keypad which can connect it to your computer and act as a normal keyboard, and you can input your digital numbers with this keypad. So as we can to demonstrate, we can connect the USB cable to this keypad, and you can see the LED screen is on, and they have some colorful LEDs to show the different colors, and we can use this knob to change LED's brightness, and yeah.
The light is beautiful.
Yeah, it's very beautiful. It's RGB lights, right? And if we are not going to connect this keypad to our laptop or computers, if we power this keypad alone, it will act as a normal calculator, and you can use it as a normal calculator. So what if we disassemble it? Yeah, you can see this is our keypad, the PCB of our keypad, and the core of this keypad is this little Raspberry Pi Pico 2, and the UMI-5, this Pico 2 is a little bit different from the official one, the green one, right? And because this is the Pico 2 designed by JLC, and the differences between this one we call the Color Easy Pico 2, right? Color Easy Pico 2.
Color Easy Pico 2.
And the difference between the official one and the difference between the official one and this Color Easy Pico 2 is the Color Easy Pico 2 uses a USB-C socket and color seal screen. You can see the color of this Color Easy Pico 2 is is colorful, and the silk screen here is indicating the GPIOs. So we can we use a swappable socket, and we can plug our Pico 2 to our keyboard, and to act as a USB device and connect to our laptop. And yeah, this is the keypad, and we have open source this keypad on open source hardware lab. So let me take a look at our sorry, let me switch the audio. Yeah, so let's take a look at our open source project on open source hardware lab. So in the open source hardware lab, you can type in the keypad keywords and search for our open source project. Wait a second. And the first one is this project, the keypad here. And you can scroll down to serve the detailed information for this keypad, including the schematic. This is the Raspberry Pi or Color Easy Pico 2 schematic, and this is the OLED screen, and you can find all you need in this open source page. Of course, including the software, the firmware, and the shell 3D file. So all you need is click here to download the files. So what we are going today is design this little keypad from scratch with EasyEDA. So if you can go to our website to get access to the EasyEDA, and we provide two methods to use our software. The first is click Design Online and choose the Pro Edition here to use our EasyEDA directly. Well, with this mode, you can your project file is stored on our cloud server, so you can proceed with your project anywhere once you have a web browser. And another way is to download a client. Here you can click here to download the client and choose the corresponding version to your computer and install it. So with a notice that we will have the giveaway time, and we prepare many $50 compound and 200 points in open source hardware lab. So we will start. We have the giveaway part. We will have maybe every 30 minutes. Yeah. So our giveaway time is at 8:30 p.m. UTC plus 8 time, and each 30 minutes. So after 60 minutes, we will have a giveaway time. So focus on, and we will continue. So once you choose the correct version of your platform or your computer, you can download it and install the EasyEDA. So once the installation is done, we can launch our EasyEDA with the icon. So this is the EasyEDA we launch, and we gain to the this is our main page, right?
Yeah.
So we can click we can press Fn and F11, or this, because this is a laptop, or you can just press F11 to get the full screen. And there is the menu bar. Most of operation option will shows in the menu bar, like create a new project, and this is our in the panel here is our quick start panel. So in the quick start panel, there are some quick start shortcut, like create a new project, open the project, and etc. You can you can look at it yourself. And in the more panel, there are some tutorials, updates, videos. The tutorial is EasyEDA tutorials and videos. You can serve yourself here. So let's begin to design our project. The first step is create a project. Well, you may see the icon here you can click here to create your project directly, or you can click File, New, Project, or use the shortcut key Shift N to create your project. But before we create our project, let me introduce a little bit about the settings. So in the settings, there are a hotkey, right? In hotkey, so in this live stream, we are using the EasyEDA standard configuration shortcut key, and you can switch or you can change the shortcut key configuration to like EasyEDA Pro, AD, or custom your personal shortcut key. So in this live stream, we are going to use the EasyEDA standard. So let's create a new project, and we can name it like EDA Keypad. Okay, and add some description. A keypad based Raspberry Pi.
A keypad based on Raspberry Pi Pico 2.
Yes. And we click save. But this is the project path. It shows the project file is saved in this in this path. Well, if you are using the online mode, your project file will storage on our cloud server. However, you can download your project file and import it to the local client. So it's creating our project. Well, this is the page, or this is the interface when we click created and the project is created. So by default, EasyEDA will create a empty board. You can see the board 1 here, and inside our board we will see the empty schematic. We'll double click to open it. It's empty, and our PCB and
it's also empty.
Yes, the PCB is also empty. So to begin with our project, the first thing is to place our component. Well, we provide a library. You can click Shift F to open it. The library provides a lot of components, and with its schematic symbol and footprint here, and you can search the keywords here like CH334 here, and you can see the different model of CH334, and we can choose one and click place, and you don't have to draw the schematic symbol. You don't need to draw the footprint, and very convenient, you can place the component and use it. However, our Pico 2, you can find a Pico 2 here. The Raspberry Pi Pico 2 or color Easy Pico 2 here with RP23 2350 MCU is not available for the footprint. So since the footprint for this development board is easy, so we will demonstrate how to draw the footprint of this development board. So to draw our development board, we need refer to the data sheet of the Raspberry Pi Pico 2. Since the color Easy Pico 2 is pin-to-pin compatible and with the official Raspberry Pi Pico 2. So there are two documents here: the Pinout document of the Raspberry Pi Pico 2 and it's brief. So let's open it. And this picture shows the Raspberry Pi Pico 2 Pinout. We can see there are 40 pins here. So
Yeah.
Let's keep in mind, and to create a new component, we're going to click File, New Component. Let's name it
Raspberry Pi Pico 2.
Yes, and the description, so leave it blank, and we can click Save. We have created a Pico 2 before, so
Yeah.
let's rename it to Pico 2 Live. So this is created in Live. Let's click Save. And now we are getting to our schematic symbol design interface. And the first thing is we need to place the pins. Of course, you can click Place. There are multiple tries for you to place the pins, draw the lines, or draw the rectangle, and draw the text or image. But here we are going to place pin first. And you can click icon here, one by one. But it seems a little bit too slow, right?
Yeah.
So there are fast way. You can click these line pins. You can place the pins in a line. However, the rectangle pin placement is more suitable for this scenario. And
It's more faster.
Yeah, we can start with a single click and drag it until the pins number meets our requirement. It's I remember it's 20, right?
20,
So,
yeah.
And click again to finish our placement. Right click to exit the placement, and we might find that the two row or two columns of our pins are too narrow, right? Too narrow. So we can select the right column and drag it away from the first column, and well, that's good, it's decent. So this we are finished our pin placement, and then we can draw a rectangle here, and that looks like a component.
Yeah.
So the next step is to define the pin name, right? Pin name here. Of course, we can open the datasheet of Raspberry Pi Pico 2, and this one, we can see the pin definition like GP0, GP1, GND of each pin. So we can type in its name, but it is a little bit too slow, right?
Yeah.
So in EasyEDA, we provide a tools. We provide an advanced symbol wizard here. You can modify the pin name at once in here. So since we have prepared pin names in a CSV, we can import the pin name. and we can. This is the pin names file. Is stored in storage as a CSV file. You can download this file on the internet. So we can open it and import to EasyEDA, and all the pin names are imported at once. Wow. It's a very quick way. And of course, after you are completing your pin name, you can click export to save your pin name file. So let's click confirm here to import. It seems some version conflict here.
Well,
it's disappeared. Never mind. Let's just type in our name one by one. So after what about after we finish this component, we can have a giveaway time. So let's open our component. So how to open our component is we can serve to library. Live screen we just created, the Raspberry Pi.
Here.
Yes, we can go back to our Raspberry Pi. And so since we have created a Raspberry Pi before, so we can show you what's the result of importing the CSV file correctly. Well, this is the when we import the pin names correctly. Well, it will automatically update to this component. Well, after importing the component schematic symbol is complete. So we need to add a little text here, like a Raspberry Pi PQ2 and place it on here to indicate the component model. So the next step is to create a footprint. Well, to create a footprint, well, you can see by default, if this component is newly created, the footprint here is empty like this, and we have to create a footprint for this for the Raspberry Pi PQ2, and we can click File, New Footprint here, and name it as Code 2. But then we are getting to our footprint designation interface. So for the Raspberry Pi PQ2, we can refer to its datasheet to find out the pin distance. So the pin distance is 17.78, and this is the horizontal distance, and the vertical distance is 2.54. So we can use, of course you can click here to place the pins one by one, but like we did in the schematic, we can place a rectangle paths and click and drag. We can the horizontal distance is 17.78. We press tab, and the amount is 0, and the horizontal distance is 2.54, and the amount is 20. So click, maybe I move the cursor so we can place again. We have to zoom out, and we find that. So this is horizontal 17.78, and amount 0. yeah, we need to 20 0 2.54. Oh, this is defined by our cursor. So yeah, this is good. We double check 0, 20. Okay, every parameter seems good, and we can press enter to finish our placement. And the 20 pins are placed at once. Oh, sorry, 40 pins placed at once. The next step is to draw the frame for it. The frame of Pico 2 is 21 here, 21 by 51. And then we can switch our layer to top silk screen layer and click place.
This outline is top silk screen layer.
Yes. Click the rectangle, and we can like we place the pins before, we can enter the width of the outline is 21 and by 51. So that's finished the rectangle drawing. After we join this top silk screen layer, we can we want to move these 40 pins, right? So if we select these 40 pins, the rectangle will be selected also. So we want to lock this layer, so we won't select the top silk screen layer, and we are move these pins in our frames, right? And there are accurate position defined here, but we are since we have no requirement for the precise location of each component or for pins, so we just roughly placing here. And the next step is to draw the socket, and the socket location here is 8 millimeters and 1.3 millimeters here. And also we will drawing on our top silk screen layer, and let's unlock it. And it's 8 millimeters by 1.8 or 1.3, 1.3, right?
Yeah.
And that's finished. So and we are finished our footprint drawing. So you can fine tune the footprint, like to adjust to fine tune the location of each pins, or including some silk screen. But for our live stream, we just leave it alone. You can you can modify, or you can have a deeper design for your own footprint based on this specification. So when we finish our footprint drawing, we can bind our footprint to the component by clicking these 3 dots, and we can, in our personal library, this is the personal library I just created, and find the footprint we just created, and click it and select it and confirm. Then the footprint is bind into our component, and go back to the schematic interface. In library, we can find our component just created in here, and if we click place, we can now we are yes. So we can place our component to here. So it's 8:35 now. So let's get into the giveaway time, and we will give away to our we will give the compounds and the points.
Maybe you have learned how to join a component's symbol and footprint. Now we are playing a 3-2-1 customer code game. Here's how it works. I'll count down 3, 2, 1, and everyone sends their customer codes.
Or I can close my eyes and pick one of them randomly or something. Or you can when she says start, you can sense your customer ID, and when she says stop, I will close my eyes and randomly picks one of your customer ID. So you can say starts.
Okay, let's begin. 3, 2, 1. Okay.
So I will close my eyes once you have sent enough customer ID, and I will pick your customer ID randomly by closing my eyes. So it's
Which lucky one?
so let's begin our random pick. Dan Boyum, am I pronounced right? 2207045A. Congratulations.
Congratulations.
Dan, you won the $50 compound and 200 points for the for in open source hardware lab, right?
Yeah. These points can be used on OSHW lab to coupons, amazing gift cards, get gifts, and more. Maybe you can choose something you like.
So let's go back. I'm gonna take a little break. So let's go back to our schematic drawing. What about take 2 minutes? 2 minutes break, and we will go back to our schematic drawing. So let's take 2 minutes. We will start our live stream on 40. Yeah, on. So welcome back. So we are going to give away another compound and 200 and the points. So when Selena says 3, 2, 1, the first one who sends your custom ID will be the luckier to win the prize. So
good luck to everyone. 3, 2, 1. Let me see.
Okay, the winner shows it's Boeing ranks. Am I pronouncing it right? The 7978038.
Congratulations.
You won the prize. And our staff will give you the compounds and the points.
Yeah. The compounds will be sent within 3 business days. You could also send emails to me. The email address is selena@easyeda.com.
So let's back to our schematic drawing. And before we place the component, we need to confirm our functionality, right? So for this keypad, it got a where's the play? So since we are going to design its functionality, right? Our keypad will have a screen, a knob here, FN, and the key, and the LEDs here. So what we need is LED screen or OLED screen, a knob for the parameter adjusting, and the LED like a colorful RGB LED, and our key socket, right? So since we have find our component in earlier, so we can just not this.
We still have 5 components to join the schematic.
Yes, we have choose the WS2812 as our LED and encoder and our hot spring, and we can find the part number here, so we can copy the part number and find this component in our library, in our system library, and this is the socket. Let me wait a second. Sometimes it may not showing up, but we can use it anyway. And the LED here, this is our LED, and encoder. We need an encoder. Yeah, this is our encoder. Of course, you can input your keywords to find the component which can use in your project. And the hot swap socket. Yeah, the hot swap socket. And the last one is OLED screen.
Use this part number. We don't need to join the symbol and footprint.
Yes, since we so we need 17 key switches.
17 key.
Yeah, we need the 17 switches.
17 switches.
And we can. So we have to.
Those switches.
We can copy and paste, and and place them in batch, and an external one here. And LED here. Going to place another 17 LED, also copy and paste. Oh, so before we copy and paste, it is more convenient to place the net flag. Well, let's talk about. We just play first, and I will talk about the net flag later. And the switches is connected to the GPIO of our Pico 2, and once the switches is conducted, the GPIO will receive the signal, so it will trigger the signal.
The switch is one connected to GPIO, another one connected to GND.
Yes, one end to our Pico 2, another end to GND. Or we can just like this. Yeah. And the external one for our FN key. Also, we are going to place the GND net flag for our LED and the VCC, and of course the VCC is the normally shows the positive voltage of our power supply, and to the pin 3, and we can copy the component.
How many LED?
Is 17. Yeah, 17.
Also 17.
Yes, one switches correspond to one LED.
Oh.
And extra one for our FN key. So that's all the component we need for this keypad. Right. The next step is to wire them. Right. To wire them. Since we can use the shortcut key W, or you can click place wire here to connect the GPIO to the switches. However, if you are all the switches, since there are too many switches, if you are connect to the switches all by this way, it may cause some chaos, and it will look a little bit mess.
Yeah.
So a better way is to use the net flag.
Net flag.
Yes, or net flag or net label, and we can use. You can see the net label here, or you can click place net flag or net label here, and place it to the pins on your Pico 2. And so let's name it GP0. And when the pins on Pico 2 and the switches, if these two pins are labeled to the same net label, they are regarded as electrical connected. So this is as same as this way you connect to them. So with the net label, you are avoiding to place a lot of wire on your schematic. It will be cleaner. So let's label the rest of our GPIO. We can press tab to change its name. Sorry, net label. We can press tab. GP1 here, and name our pins. And we notice this is GP26, so we can press tab again to change to GP26. Oops. And that's it for our GPIO. And we have prepared the GPIO for our schematic, so we just follow our configuration. The first row switches, they are GPIO 7 to 4. So where is 7 to 4. Now we do zoom out.
6, 5, and 4.
Yes. So we are not going to draw all the name all the schematic. I will show you the final schematic for this project, because the subsequent operation is just naming and just connect this GPIO to our. Oh, sorry. There is another thing to notice is that for the GND we are going to place the net flag. Yes, to here. We're going to
Neighbor flag and neighbor label is different.
But for the functionality, is they are working in the same principle. Maybe the name is different.
Yeah.
If we want to hide this text here, we can choose them, and on the right panel we can, in the key properties, we can uncheck this box and the name will hide to get the page cleaner. So for the pins which we are not going to connect it, like this run pin, we will place not connect flag here.
No connect flag.
Yes, and for the rest we are going to not connect flag. This we are not going to use, and the rest of them is GND, and there is a floating tool. You can place the net label, and you can place net flag directly from here. And the final one is VBus. We are going to regard the VBus pin as our VCC, and the rest of our component is powered by the VCC. So that's the net flag and net label. Once we finish our schematic drawing, the schematic will wiring like this. All the maybe you might notice this icon is a little bit different from the net flag, for the net label, and this is for the GPIO. This is for the digital input output, but like we said before, the net flag, the net label, they are working in same principle, and the net flag or net label, if they are the same name, they will connect together, so that's fine. And once we finish our schematic drawing, we need to run the DRC check for our schematic, and still there you may encounter some warnings. So some warnings which can be ignored. This warning which can be ignored, and for other warning we can take a look one by one. And this one is single network, which means the GP15 we are not use. So you can leave it alone, but you can also delete it and click and place a not connect flag here, and another district GPIO28 is no use, and you can place a not connect flag, and this one is wrong flag. We missing this one for our before, so we can place a not connect flag, and we run a DRC check again. Well, the warning we are concerned is disappear, and this is not really important, so we can ignore. So once we finish our schematic drawing, the next step is to convert our schematic to PCB. So this PCB is finished. We can move it. We can move it to. We can remove from the board. So it can now not belongs to the board 1. And in board 1 we can create a new PCB. And this is the default PCB interface with the newly created PCB. So the next step is to convert this schematic into our PCB. And to converting, we can click let me find the design. There is update convert schematic to PCB, or you can press Alt and I to convert, or you can click little icon here to convert. There's a multiple way, so let's click icon here. Since our PCB is empty, so there are a lot of change shows here, and check them and click apply changes. So our components are converted to the PCB. So the next step is to draw the frame. On the right side shows our this is our
board outline layer.
So this is the layer management. And our PCB is a 2-layer PCB. So there shows a top side. Top side you can edit the top side, top layer, top seal screen, the bottom side, and there is a other. In other we can draw our board outline. So to draw our board outline, we can click the color block here, and a pencil will appear here, which indicates currently we are drawing on the board outline layer. And to draw our outline, we can click place, line, rectangle, and drag to draw our outline. And since the unit here is mil, we can press Q to switch our units to millimeter, or you can click here to change your default units. So let's keep in millimeter, and we can place here is line here, and rectangle. And that's what about 19 millimeters by 100. and click enter. So that's the outline of our frame. And if you want to like this, the outline of this frame here is a 90-degree corner. If you didn't like, you want a round corner, you can set its corner radius. You can click on this frame and set the corner radius like 5 millimeters, and the corner here will be rounded, and the board may looks more beauty.
Yeah.
So at the same time, you can change the width and height here. If you are not satisfied with the width and height you are earlier set. And once we finish our frame design, we can lock the board outline layer here, and you cannot select the you will change the outline here. So we talk about every 30 minutes to have a giveaway. So
It's time.
it's time to have a giveaway, and after the giveaway we will have a 2 minutes break, and we will be back. So what about you choose 两个来，我去3个时间。So the Selena will have our giveaway time, and we will be back after the giveaway time, about 2 minutes.
It's the same rules, and let's begin. 3, 2, 1. Let me see which one lucky guys. Which one? ALHSIN. Congratulations, you have got our coupons and 200 points. He will come back after 2 minutes, and when he back, we will still have a row to give away. We're back for a second.
So welcome back, and we are continue to our PCB drawing.
We will have a
Before we also when we're back, we will also have a giveaway time. What about the last time we 3D1 or random pick? So let's 上一次是321吗？
也可以的，both okay.
上一次是
321。
So this time we will go into random pick. When Selena say begin, you can send your customer ID, and I will randomly pick and close my eyes and randomly pick one of you customer ID. So
okay, 3, 2, 1, let's begin.
So you can send your customer ID. Okay, I see. It's
I will send you coupons and 200 points.
So there's a lot of IDs. I will randomly choose one.
Which one?
MXTTHIXU. So congratulations, you won our compound and 200 points.
Congratulations.
Congratulations. So after our giveaway time, let's get back to our PCB drawing. So we are going to. So the most important things is to manage your component on your PCB. So once you have to well manage your wires, so here is some demonstrate of how these keys are managed. Like we are going to use some I/O here to connect to our first row keys and second row keys here, like this, and this way we can finish our wiring without without the cross. So the component placement is very important for PCB layout, and when you finish your placement, you can begin your wiring. But in this case, I will just show you how to place and how to adjust your component. We are not going to place them in a right way. So we are here we're just showing you how to place them. So with the Raspberry Pi Pico 2, we are going to place, since our keypad, this is front side and this is back side, and our Pico 2 is placed on the back side. So and the LEDs and the sockets are also placed on the back side. So we will set this component to the bottom layer. Of course, you can set them to the top layer as you like, but here we are going to set them to the bottom layer. So we can choose them by press Ctrl to multi-select and change its layer to bottom layer.
In this board, this is the bottom layer and this is the top layer.
So let's place our Raspberry Pi Pico 2, and once you have to manage your placement, you may refer to your schematic, and there's a quick way to work across from the PCB and schematic. You can right click on your Windows tab and choose horizontal split, and here you can, when you select the component on your schematic, like we select our Pico 2, and your PCB will shows its position and will highlight the corresponding component. So so what we want is we want to find a like encoder. So this is our encoder. We can quickly find them, and we can drag. Yes, use your right click to drag the PCB and place it here, and press space to rotate. Every space rotate 90 degrees. If you want to rotate it with a specific angle, you can go to right panel and find the rotation here to enter your rotation angle.
This is the encoder here.
Yeah, this is encoder. And we
This
are going
glue.
to find our FN key here. Also, this is LED. We are choose FN key here. We are going to place it here, and its LED is this one, and we are going to drag it here. And for the rest of our key of our socket, we can multi-select and drag it to here. Again for this row, this row, and for the third row, and for the last row. And LEDs, we are going to select this row. Oh, they are on top layer, so we have to change its layer to bottom layer. Yep. This is the first row. This is the second row. This is the third row. The last row. Once we this is OLED screen, we can place our OLED screen here. Yeah. So we can close our schematic now. And the next step is click this little triangle here. We can hide our layer management, so we can get a bigger design interface. Oh, this should be on
Bottom layer.
the bottom layer. Yes, bottom layer. So you might notice that there are some arrows right here. This is because this footprint has a slot here and a pad here. They are getting too close, and if you think this is okay, then you want to ignore the arrows, and you can go you can go to like here design. We have a design rule. In the design rules, all the DRC track will based on the design rule. So our copper thickness is 1 ounce, and we can find the SND, the minimum SND pad distance between the slot region, and is here, and we can switch to minutes to mil, and the minimum distance between the slot region and SND pad is 6 mil. So it is a little too big for the current project, so we can minimize it to 3.8 mile, and we click apply and confirm. You can see when we update our component, the arrow is disappear. It may not it may not suitable for all the project, but it's suitable for our project. So for the other design rules like track thickness, when we place our track, the default track will be 10 and it's defined here. And if you want to change your default stroke width or track width, you can change it here. And yes, that's it. And after you modify your settings, you have to click apply and confirm. And so in here we just leave 10 miles track width. And so we want a alignment for these switches. And let's move up a little bit. We can use our arrow key to move the component. So we want these 4 keys line up on the top. We can multi-select and
align top.
Yes, align top. We got a shortcut. We got a function here. We can click the triangle here and click align top, or you can use the shortcut key and Shift Control O, and they will align top. And then we are going to adjust its horizontally. Of course, you can get a fine adjustment by using the center X and center Y here. But here since we are not require a high accuracy, so we just adjust them by our hand. Okay, this is let's align a little bit. So this column should align left, right? So we can use the shortcut key Control Shift and L for left. And let's move up these switches a little bit. Yeah, then these four should align left. Oh, sorry, align right.
Maybe choose.
Oh, I pressed the wrong key. Align right. Okay. And this should align left. These 4 should align left. And this should align top. Up. Or sorry, I forgot the key. Align top. Oh, it's O. Align top. Align top of this. So now we are finished our key placement.
It looks better now.
Yeah, it's look more organized.
Yeah.
And then we can place our LEDs into our sockets, and so it can give us a beautiful illuminance.
We have seen that.
So it may take some time to get a fine adjustment, but let's just quick finish here. Here we just roughly placing here.
One by one.
Yes, because there did too many keys right here.
Yeah.
once we finish our placement, the next step is to wire them, right? Since you can see there are many red line here, is a little bit complicated, but we can manage this red line here by clicking the project design net, and there got a red line here, and we can see all the red line. The red line indicates the wire you have to dump. So typically we will finish, we will wire. Oh, here is a little, is too close for the border.
Yeah.
So we can move. Oh, we can move away from the border a little bit. Okay.
Now it's right.
Now it's good. So we can hide our ground red line here. Will look a little bit better. So the next step is to wire them, wire the rest of them, and for we can first wire these three GPIO 10, 11, and 12. We can click W, or you can click place. There are a place
line.
No, it's not line. It's so
Here.
Yeah, this is called single routing. It's, oh, sorry, it's in route. In route, there are single routing. You can click single routing here and finish your routing. And this is the width of this track is we can press Q to switch our unit and click on this track, and we can see the line width is 10 mils, and we can change its width here, or while you're routing you can press tab to modify its width, like to 8 miles or 8 mils or 10 mils. Let's leave it to 10 mils. And as the same, we can route the GP12 here. So the rest of your work is routing. It only got the routing. So when you well manage your component's position, you can route your component in an elegant way. So typically we will spend a lot of time on the component placement to place them in a good location, so we won't route this in a complex way. Let's continue to these switches, and now we are routing on the bottom layer. So if typically we want to route our track, or we want to route our PCB in a single layer, so we can, since our components are placed on the bottom layer, we can change these tracks. We can multi-select them, and on the right side we can switch them to the bottom layer. And for the shortcut key to switch between different layers, we can use the B to switch to the bottom layer, or press T to top layer, or you can just click here. So let's route the GP13. Also, the GP13 show goes here. Let me show. Oh, maybe we should route the GP14 first. And this goes here. So there will not got a block.
Maybe GP14 can go in top layer.
GP14, but the LED is on the bottom layer.
Yeah.
So for the rest of this GPIO, we just literally routing for the GP9. So I'm not going to route all of this. I'm going to show you so I'm going to show you a finished project, and just that's the same project here. Wait a moment. Also, I'm going to copy this board. So to demonstrate, I'm going to delete this copper to show the. So this is the final routing of this PCB. And when we have managed all the components, our PCB will routing like this. And
the wiring are all in bottom layer.
Yes, except this need to get a. Oh, sorry, then let me delete something irrelevant. So this is how it looks like. Well, for the VCC, we are going to route a more like we will give the VCC a wider width for the VCC. So this is should be noticed, because the current going to VCC will be large. And let's go to our red lines, and we will see the last network is our GND, and I see it's 30 minutes now.
Yeah.
And let's go to the giveaway time, and we will get back 2 minutes after giveaway.
Let's begin now.
The
same rule.
Yeah, the same rule as the last time. When Selena say begin, and we will begin our. I will begin a random pick to your customer ID. So.
Okay, 3, 2, 1. Let's begin.
Okay, you can send your customer. You can send your customer ID.
We will send coupons and 200 points.
So there are a lot of ID. Let me take a random pick.
Which one?
So Kevin, right? Kevin, you won the prize here. You won the $50 compounds and 200 points in open source hardware lab. And congratulations.
Congratulations.
So we will be back after 2 minutes. So welcome back. When we go back, we will. 再说一次.
Okay.
We will have our last giveaway for our last giveaway. So you, as seen before, you can send your customer ID, and I will have a random pick and to choose the lucky one.
3, 2, 1, let's begin. Which is the lucky one?
So let me random pick. Osman Pasha's DIY. You are the lucky one, and congratulations.
Congratulations.
2408649A. Congrats. And let's go back to our PCB drawing. So the last, let me recover the PCB. Let me check. Whatever. So the last thing is to connect all the GND. So you may notice, you may think we use the same way as before. We draw a line and connect each GND, but it's not necessary because there are a lot of GND here, here. So the recommended way is to use a copper to connect them at once. So here we provide we can go to place copper region to place our GND copper. Now we are working on the bottom layer, and we click and drag to define our area and click again. In the pop-up window, the net, we are choosing the GND by default. Of course, for other area or for other usage, you can choose different nets. But here we are going to connect the GND and click confirm. We can see the so here's the vias we placed before, and to demonstrate the operation we are going to delete them. We will place this GND later. Oh, sorry, we will place these vias later. Okay, so now you can see the red lines for the GND is less than we placed the copper before. And let's go to the top layer and place the, we can click icon here to get a quick access, and we can place the copper region again, GND, and confirm. So now there are only 1, 2, 3, 4 red lines we have to connect, and obviously on the top layer, the GND, they are here they are connected because the copper area on the top side is large. But let me switch to the bottom layer. We can find that the copper region here and to here, they are isolated. So to connect them, we have to use vias to connect the copper between the top layer and bottom layer. To place a vias, we can click the icon here, or you can click place VS, or you can see the shortcut key here. You can press V, shortcut key V, to place a VS quickly. And when we place our VS, it will automatically detect the net around the VS. So here the system detects we want to place a GND VS here, so we did not need to change the net here. And like as the same way, we can place a VS here, and now we can see the red line between these two copper disappeared because we used the VS, and the VS connected to top layer. The top layer can connect the GND together. And the next step is to connect these two copper. Also, we can place a VS and place a VS here, and it's finished. These two copper are connected, and again place a VS here, place a VS here. Now all the GND are connected by our VS, and you can see the red line here. There are no red lines. So our PCB, the wiring is finished and all the connections are complete. Of course, we usually will place more VS to enhance its ability to carry the current. So we will typically place more VS, but for some specific situation, you may notice the VS placement, because for the noise sensitive project, your GND may affect your like DAC or ADCs or other noise sensitive devices. So, but for our project, it doesn't matter. So we can place our VS randomly, or not the randomly. We can place our VS roughly, and shows no error is okay. So the last step, and you may want to you want to place some image to your PCB. So for this, we can click place image. You can place a logo here. The conversion encounters an issue. We can check again. And on the right side is the preview. We can adjust these parameters to get a better view.
Maybe you can choose the colorful silk screen.
Colorful silk screen. It is also based on this. Yes, you can. If you are placing the colorful, or so this is SVG file may encounter some problems, and so you can anyway you can import your PNG file or a JPEG file to this PCB. By default, it's white or it's black silk screen. However, if you are using our JLC PCB color silk screen technology, you can print your silk screen. You can print your image in color, like this Easy Color Duino 2. So when we finish our PCB, and we are recommended to conduct a DRC check. So in here, DRC, we can click check DRC, and yeah, there are no warnings, no errors. Then the next step is to file, export our PCB file as a Gerber file, and you can submit your Gerber file to JLC PCB and manufacture your PCBs. Well, and in EasyEDA, we provide a 3D preview and 2D preview for your PCB. And in 2D preview, we can see the PCB of your the final PCB of the final PCB, and we can view the top side here or bottom side here. Of course, you can change the board color, and for my preference, I prefer the black. The black seems looks more technology, right? And also this
is the black.
Yeah, the EDA pad, the keypad here use the black, use the black board color, and also you can preview your PCB with 3D, and it may cause a little time for render. When the 3D model is based on internet, so you may encounter some internet issue. So anyway, you can proceed with your own project with this render. Let's restart our software. And so when we finish, so this is the completed board. We can move the board back to our, move this PCB back to our board. Yeah. Yeah, since this board is connected to the, I know why. The 3D preview show corresponding to the schematic. So this is the 3D preview of our finished PCB, and you can preview it, and you can see the there may be some offset, but you can adjust this offset by modifying the 3D model. It doesn't matter.
This is very similar as our board.
Yes, if we change its board color to black, and it totally the same as the board as we manufacture. So so when you get your PCB, you have to solder it right, and you have to refer to the schematic. You have to refer to schematic and find the silk screen on your PCB. But on EasyEDA, we provide a soldering assistant tool which can boost your soldering. Like it's in when we open the PCB in the tools. In here we can find our soldering assistant tool, and in this tool on the right side we got a 3D preview. We got a 3D preview here, and on the left side shows your component and with its designator. Since you can once you have finished any component, you can check the box on the checkbox here, or if you are soldering the component one by one, you can see a splitted list here, and when you finish your soldering, you can click, you can check the box, and when you selecting this component, the 3D view on the right side will automatically locate your component, Like we want to find where is the LED 5, we click here and we can find our component. And this is a very convenient way to help you to find a component.
This board's component is not complex. For the more complex board, if you have to solder them, this tool is very useful.
Yes, when the components for this board is not that complex,
Yeah.
You only got 5 types of components. But for more complex, like the USB hub, that's not like the DAC or some or other complex board. This tool will be useful, and it can be saved and it can be exported as a HTML file. When you export this file, this tool can work standalone. It doesn't need to launch the EasyEDA, and you can open this HTML file with your mobile phone or with your pad, with your laptop or anything, which can install the browser. That's very convenient for the soldering.
Yeah.
So it almost that's typically all the content for this live stream, and we are going to answer some questions. If you encounter any questions, you can send your chat, and we have 5 to 8 minutes to answer the questions. So let me check your chat. Thank you, James. Thank you. Because typically we want to the GND copper as big as possible. If you wire some wire on a top layer, half on the bottom layer, some GND connection may encounter some issue. You may not be able to connect the GND. So typically we want to draw all the wires on one layer. That's good for your GND, and it will lower some electrical noise. Yeah. Would the auto router have help with the routing of this board? Yes, for this board, because it doesn't run some high-speed signal, so the auto routing is good for this board. Well, this board, once if you are not concerned about if you are not concerned about the elegance of the wiring, the auto routing is okay. Could you guys help me with my electrical engineering skills, please? For the future, our channel will have some electrical videos and help you to learn some electrical knowledge. Yeah. So focus on our EasyEDA channel. Why LEDs are behind? This is one type of LEDs. Well, you can see with this, and this is one of model of WS2812. But you can use with this model. You can see, well, it seems a little bit. Well, with this model, the thickness will be thinner. So once your space are limited, this type of LED can save your space. once the LED is mounted on within the PCB, right? So it won't have it will bump up, so it can save the space. And if you are not concerning the thickness of your installation, you can use the simple top mounting WS218. Can you show us how the PCB looks in person? We can show you PCB in a bigger image. This is our PCB, right? Since it's soldered with the socket and with the Pico tube, it's difficult to if we want to. So we have to unmount these keys to show you the PCB. So wait a minute, we can unmount. 你帮我拆一下我这个。
Okay.
Let's Selena to disassemble this EasyEDA pad. We could use a transparent PCB also. Let me ask our staff. 我们有那个透明的 PCB 吗
？FBC？
不是，他的意思是那种透明的。应该
好像见过。
有见过，但是现在
好像
在这应该还不行。With the pity that GLC PCB not support the transparent technology, so this is a very advanced technology. I admitted that it is beautiful, but we are not able to manufacture this. And this is the PCB we after the manufacture and after the soldering. And here is the bottom side, and here is the top side. The switches are mounted in this way. And like this, it's a hot swap socket here, and we can pull it out to change our switch. Yeah, and that's it. It's a black board with a white silk screen, and the encoder here.
Any questions?
So okay, so that's all for today's live stream. And if you are interested in this with this EDA pad, EDA keypad, you can go to our website, Open Source Hardware Lab, and search search keypad to get access our open source project. And we have also upload a series of EasyEDA tutorial. You can go to our YouTube channel to watch our videos and to learn some skills of our EasyEDA. So thank you for watching, and thank you for watching our live stream, and goodbye, and thank you all, and goodbye.
Thank all of you. Goodbye.